Hello, this is John Lima, software engineer at Unidata. On this week's MetPy Monday, we're going to talk about Conda environments, what they are, why you might want to use them, and how to set them up. Now, if you don't have Conda installed, go back and watch some of our earlier MetPy Monday episodes to install Conda on your machine. If you go ahead and open up a terminal, here I've got a bash shell open, we can type conda -- version to make sure that your machine sees the Conda installation. In my case, I'm running 4.2.13, which is the most recent as of this recording. Conda allows us to create environments where we can sandbox a certain version of Python and packages that go with it. So for example, if you had some applications that have not been updated to run in Python 3, you can have a Python 2.7 environment with the packages that those applications need to run. You could have a Python 3.6 environment that you use for your research, where you don't update or change any of the packages until you verify that they don't break your research code, or even an environment for a specific paper. And then you can have some environments to play around with, some to develop in, some to try updating things and see if everything works or if things break. The nice thing about environments is they're really just directories on your machine in the Anaconda or Miniconda folder that you can throw away when you're done, or you can use the command line to do so. So they're really not all that space intensive, and they're a great way to try something and then toss it if it doesn't work without messing up all the paths on your machine and not being sure which Python you're pointing to and the mess that we used to have to deal with before this. So let's go ahead and create our first environment. If we type conda env list, you can see that right now we just have one environment, which is the root environment. The asterisk means that that is the environment that is currently active. So that's the default environment from the install. We're going to create a new environment with conda create -n for the name. We'll call this playground, since it's somewhere we can kind of mess with the different versions of packages and then throw it away when we're done. And we can specify that we want this to be Python 3. Now, since I installed Miniconda 3, that would be the default, but you could specify Python 2.7 here if you wanted, or you could specify if you wanted Python 3.4 or whatever. But we're just going to say that we want the most recent version of Python 3. So we go ahead and press return, and it's going to say that it's going to install these new packages. We hit enter to accept the default yes answer and let the packages install. Okay, now that everything has run, you see it tells you the directions at the bottom of exactly what to do. So to activate the environment, we're going to type source activate playground, and to deactivate it and go back to the root environment, source deactivate playground, or just source deactivate. Now, if you're on Windows, the source will not be used. It's just activate playground or deactivate on Windows machines. On Mac and Linux, use source. So now if we run conda env list again, you see that we have that new environment, and it's just in Miniconda 3 /ems /playground. Again, you could go delete that directory if you wanted, or I'll show you how to do that from the command line in a moment. But let's go ahead and activate this environment. So source, activate, and then the environment name. And you see now in front of our prompt, we have the environment that's active in parentheses to let us know that we're working in the playground environment. Now, if we want to install a package in here, we can just conda install like we normally would. So in this case, I'm going to install CartaPy, which is a mapping utility. I'll say yes to go ahead and proceed with the installation and let all of these packages install. Okay, now that those have installed, we can go ahead and run a conda list in this environment and see that we have a lot more packages installed, including CartaPy. Up here, we have CartaPy 0.15.1. Now, if we go ahead and deactivate this environment, source deactivate, we're back to the root environment and conda list does not show CardaPy installed because it's not installed in the root environment. Another way to create an environment, say that you want to be able to recreate the same environment with the same packages over and over. For example, we want to be able to recreate development environments here that we can work with, and then anybody else that wants to develop the software can work in. Or say you have an environment that you want to distribute with a paper so that everybody can download and activate that environment and run the code that goes with the paper. You can create an environment.yaml file or environment.yml. I'm going to show you an example environment file that we use for running our Unidata Python training workshops. So I'm going to go ahead and open it in VI. I'll have this file linked in the video description if you'd like to go download it yourself. And you can see here that the first line we specify a name for the environment. It's going to be called Unidata-workshop. We add the Conda Forge channel, and then we list dependencies. So Python 3, NumPy, Matplotlib, and so on. And then down towards line 20 to the end of the file, we say that Python AWIPS and MPL data cursor will also be installed. They're not available from Conda Forge or the default Conda channel, so we're going to install those with pip. So by handing somebody this simple file, they can recreate the exact same Unidata workshop environment. And that's why it's so useful for us to be able to have students in the workshop all work in the exact same environment and not have to type all of these install commands each time by hand. I'm going to go ahead and exit out of that. And in this case, as long as you're in the directory with the environment.yaml file, you just have to type conda env create. Conda will look for an environment.yaml file. It will read in everything from that, parse the YAML, and tell you exactly which packages need to be installed, and go ahead and do it. Okay, so after a few minutes, that environment has finished creating. Now if we run conda env list again, you see that we have our root environment, playground, and Unidata workshop. So let's say that we're done with our playground environment. Either we've broken it some way inside, or we decide that we don't want to use the packages that we had installed in there, or for whatever reason we're ready to get rid of it. We can use conda env remove -n for name playground. Ask if we really want to remove all of this. We say yes. Unlinks the packages from the environment and destroys it. So now if we run conda env list, we see that we're down to 2 environments, root and Unidata Python workshop. So I hope you found this helpful, and I hope that you start using environments in your research workflows. It's a really great way to be sure that you don't break things you don't want to, and provide a safe environment to try other things, as well as just to manage Python versions as we're in this Python 2 to Python 3, a little bit awkward time during the switch. Thank you for watching, and we'll see you on the next MetPy Monday.